Amy Bonka, a PhD student here at UAB in the Department of Biology. I'm in Dr. Thane Whipple's lab, and in our lab, we work with turtles. And we're looking at their biology, their conservation, their ecology, their physiology. And so part of one of the programs that we do is a Diamondback terrapin conservation program. So today, we're going to talk about that program and what we're doing to help conserve those turtles and how we use different parts of science in doing that project. So first up, our species, our Diamondback terrapins, are a marsh turtle. So these are turtles that live in brackish water. So that means they live in the areas where that salt water from the ocean and some of that fresh water mix together, and they're going to live in those areas with kind of some marsh grasses and things like that. Kind of like some of those habitats you might see if you go down to the beach. Now these guys, the ones that we work with, are actually right here in Alabama. They're in South Alabama. So if you go south and you go down near Mobile, and you head a little bit further south towards Dauphin Island, right around in that area is where we work with these guys. So what we do is in the springtime, we go out, so about April, May, we go down there and we set up these kind of fences and some buckets and collect females that are coming ashore to nest. So those females, they come ashore, they'll find that fence, they'll kind of crawl along that fence, and then they'll get in this bucket. It doesn't hurt them, we check them every day, and we bring those females back here to the lab to lay their eggs. So then, once we have those eggs, we're going to incubate them here in the lab in these incubators. What's interesting about our Diamondback terrapins is the fact that they have something called temperature-dependent sex determination. So that means that our turtles, the sex, so if they're male or if they're female, is going to be determined by what temperature those eggs incubate at. Now this is a little bit different from you and I. So you and I have sex chromosomes, so those are going to determine if we're male or if we're female. But our turtles, the temperature that those eggs are at is going to determine if they're males or females, so if they're boys or girls. So like I said, we'll have our females here, they'll lay their eggs. Once they've laid their eggs, they get taken back to South Alabama, they'll get released right about the same area that they were caught in, and we're going to incubate those eggs here. So let's look at that process. So here we have some eggs. Now these are not actual real eggs. These are some of our 3D printed eggs, so you can kind of see roughly about what size and shape they'd be. Our terrapin eggs are kind of this oblong, almost kind of a football shape. They're a little more rounded on the edges than a football would be, but that kind of longer shape. And so what we'll do is we'll take these eggs and we'll put them into our incubators. So let's look at our incubators. Now we have a couple different setup here, and what you'll notice is that our incubators are going to have signs telling you what temperature they're at. So in this case, we see that this is a 26-degree incubator, and we also have a 31-degree incubator, and we also have a 29.4. Now, these temperatures are important because for this species, those are the temperatures that are going to produce either all males, so our 26 is going to produce all males, all females, in the case of our 31, so that warmer temperature is going to produce our females, or in the case of this middle temperature here, we'll produce roughly 1 male to 1 female, so we can get a mixed sex ratio, about 1 to 1. Typically, we put most of our eggs into either our male or our female, and so what we'll do is we will take that clutch of eggs. So a clutch of eggs just means that it's a group of eggs that have been laid all by the same female. So we have one female that, say, laid all these eggs here. Let's see, we've got 2, 4, 6, 8. So 10 of our fake eggs. We'll pretend like she came from one of our females. And what we would do is we can put maybe half of these eggs into our male, and we can put half into our female, or we can put all into one or the other. So let's do that. Let's put our eggs into our female producing temperature. So in here, we have our incubators. And so these incubators are a water bath incubator. So what does that mean? That means that we have this kind of big tub in the bottom, and we have this insulated box. And in this tub, we have some water, as you can see here. And we'll have a thermometer in here, we'll have a bubbler, and this will help kind of regulate the temperature of the water. And that will in turn ensure that it's nice and humid in here. So it's usually at about 100% humidity. which is important for our eggs while they develop because we want to make sure that our eggs stay nice and moist while they're developing, because moisture is important to our eggs. So what we'll do now is we would have our little baskets. So you have something like this in here, and what we can see is that we have different compartments. And so this is important because this helps us keep our clutches of eggs separate. So we know that whatever eggs are in each of these containers go directly to one of our individual females. So we know exactly which female lays these eggs. So what we'll do is we'll take our pretend eggs and we will stick them in here. We'll pretend like they're real. And we would just stick them in one at a time into our little container like this. And as they go in, they'll just kind of set next to each other. So you can go. And so we have all these eggs in here, and we would know exactly which female these eggs came from. Just like that. So there we go. So we got some eggs in there. And now they're going to incubate in here for roughly 2 months or so. And they will stay in here the whole time. We'll check on them. And then after that, roughly 2 months or so, they'll hatch out and we'll have some little hatchlings. Now again, we'll know which female these hatchlings came from. And so we can give those hatchlings individual ID numbers. So now, what do these hatchlings look like? Let's actually look at some turtles so we can see what they look like in this process. So first up, we'll put on some gloves for safety. So we'll get our gloves on real quick. And so we're going to start with one of our hatchlings. So first up, this guy was hatched out in 2019. So this was about roughly August of last year. So last August. And this is what they look like pretty soon after hatching. They're about this small. And we can see that they're nice and small. They're pretty cute, I think. And we'll notice that they have this kind of distinctive speckling pattern on their skin. And we can also see that they start to have a pattern on the back of their shell. So we have two terms associated with our turtles. We're going to have a carapace and a plastron. So the carapace is actually this back part of the shell that we see, so kind of the top part here, all of that. And then the plastron is the bottom part, so this underside, basically kind of like their belly area. With these guys, we'll see that this specific one has kind of this nice patterning on the plastron. That will start to go away as they get older. It'll kind of become more of a uniform color down there. But we will see these kind of speckles and coloration that remains on the top part, that will stay. And again, the coloration, these nice speckles that we see on the skin will stay throughout their life. So this again was a 2019, so August, what is that, roughly a few months ago. In August 2019, this guy hatched out. So if we want to see how they grow over the years, because with our program, we keep them here for about 3 years or so. And we're doing that so that they can get to be a larger size, so that when we release them, there's less chance that predators will eat them, and they have a greater chance of survival. So we're trying to help this population recover. This population, it used to be a very, very large population. However, a lot of different factors affected it. There was some over-harvesting, there were interactions with crab traps, a bunch of different things that contributed to kind of the decline of this population. Some previous students have done work with some of the crabbers and worked with crab traps. And so we're really focused mostly right now on some of those predators and helping to release hatchlings that are a larger size so they're less likely to be eaten by those predators, and again, they'll have a better chance of survival. So they stay with us, like I said, for roughly about 3 years. So that was kind of our first year, so that's 2019. So let's look at a 2018 year class. So this guy's been here for about a year, and we can see that in that time we'll get a little bit bigger. So here is a 2018 turtle, and we can see that we have that kind of same speckling pattern. You will notice that some of our turtles have more of a light coloration and some have more of a darker gray coloration. That's normal. They have variety, kind of like you and I have variety in our hair color. We will see those specklings though, and then what we'll see is kind of that similar coloration along that carapace, so again, that top shell. And looking at the bottom side, we'll see that that patterning is starting to fade a little bit as they age. and we see more of this kind of yellowish coloration coming in. And so again, this is about a year old. So you can see that in that year, they get to be quite a little bit bigger than they were in that first year. Now they need to be a little bit bigger still before we release them. And so let's look at that next year class. So this next one that we're gonna look at is a 2017. So it's been with us for about 3 years. We'll probably get released later this year. So we release them in the summertime when it's nice and warm. We don't want to release them when it's really cold out like it is right now. So we'll take them down there in sometimes in the spring, but throughout the summer and into early fall when it's still really nice and warm for them. So this is one of those 2017s, and we can see that they've gotten quite a bit bigger. He's now basically filling my hand, and we can see that that coloration, we still have some of that patterning, but it's not quite as obvious as it was in that early year class. We still see that really nice coloration in that skin though, that nice patterning. Now he is showing off for us this really nice tail that he has. Oh, and of course I said that he wants to hide it. We'll see if it comes back out. But that's one of the ways that we can tell our males from our females, because our turtles are gonna have something called sexual dimorphism. And that means that there's basically differences in the way that our males and our females look. And one of those differences is this nice long tail. So our males have these really nice long tails, in contrast to our females, which have kind of like short little stubby tails. And so just to kind of give us a little reminder, here is that kind of about a year difference between these two sizes. And then from that very first one, we can see how we went from that kind of really small to this bigger size. So this little guy, greater chance that he might be eaten by something if he just crawled down, but this guy, less chance that those predators could eat him. Better chance that this guy can survive. Now, before we release them, they get a couple things done. So these guys are cleaned and fed every single day. That includes weekends, that includes holidays. So we are in here, there's a great team of us that clean and feed these guys. Now before they're released, they are fed some live food, so crickets usually, but some live food so that we know that they can hunt for live things and a better chance that they will feed themselves out in the wild, and we've had great success with that. We also will tag them so that we know which individual turtle it is if we catch them again. And so we do that in 2 ways. We do that with something called a pit tag, and we do that with something called a shell tag. So a pit tag is kind of roughly the size of a grain of rice. So if you've had rice recently, maybe for lunch or dinner or breakfast, you kind of remember about what size that is. But here's an example where we can see, make sure my hands are dry, where we can see roughly how big of size that would be. So here we can see it's roughly the size of a grain of rice. It's pretty small, and it gets injected under the skin. It doesn't hurt our turtles, and it has a unique ID number to it. And so that unique number, so it's a long number, usually a combination of letters and numbers, and that unique ID tells us exactly which turtle that is. So we know what year class it was, we know what clutch it came from, we can relate it back to what female it came from, so we know a lot of information about it. You may be wondering, hey Amy, I've got these turtles, and it's got this little grain of rice, but it's under its skin. How do we get that information? How do we know what it is? We use something like this. We use this reader. It'll be similar to this. This is kind of a big one. We have some that are smaller. But what you see is right here, there is a nice little screen, and we just hold down this button, and you scan it over that organism. So we use it, like I said, with turtles, but it's also similar to what you might have if you have like a pet dog or cat that's been microchipped, and you can scan them for an individual number. It's similar to that. So that will give us that individual ID number. And so again, we'll know a lot of information about that specific turtle, which is really, gives us a lot of information, like I said, but it's going to be under the skin. So unless you have one of those scanners, it's hard to tell that information. So that's why we also have those shell tags. So our shell tags are kind of like an earring. So if you have an earring, you have something kind of similar to that. And we are going to insert these tags onto that shell And that will be an external way for us to just look at that turtle and say, oh, here's all this information. We know specifically which one it was. So let's look at what that looks like. So here on our 2017 turtle, he has one of our shell tags. And so we can see with this guy that on the back of that shell, we have this little tag. It's basically a little kind of zip tie you can see here with an individual number on it. And that will go into that shell like this. And you can see there's some space there, so he has room to grow, so it won't hurt him. And that will tell us exactly which turtle this is. So again, if we catch it, we have all that information about when this turtle was hatched, again, what mother that was, and it can tell us a lot of information for our project. Okay, so we've seen our hatchling turtles, we've seen our eggs, we saw how they were incubated, we've seen a couple year classes. Let's look at the adults. So again, we're trying to help this population recover. We're growing them up to a larger size, and then we're releasing them, less chance for those predators. So let's look at what they look like as adults. So first up, we have our adult male. So this is an adult male, and we can see again that nice kind of speckly coloration on that skin. And if he wants to stick out his tail, which he tends to not like to do, we can see this, well, he might stick it out in a minute, we'll try again. We'll see this kind of nice long tail. And we can see that this guy, not all that much bigger, but a little bit bigger than that 2017 that we can release. So, if this is our male, and I said that our males and females do look a little bit different because they have sexual dimorphism. So we're going to see some differences between our males and females. Let's look at what our female looks like. And you can see here, in contrast to this male, our females are much larger. So you can see here how much larger our females are now. Both of these are adults. So this is basically a fully grown size. They might get a little bit bigger. Our turtles will continue growing. So turtles will continue growing basically throughout life. But once they reach adulthood, they typically grow very, very little at a time. So it's not always all that obvious, but they might grow just a little bit more. So let's look at some of those characteristics of our female. Here's our female. Again, we have this kind of really big shell in comparison to that male we were looking at. If she wants to stick her tail out, which she might, we've got just kind of this little bitty tail. We got kind of this tiny little tail. And I'll try and get our male's tail out again in just a minute. They don't like to stick their tails out. We'll also see that she has this really nice big head. And along with that big head, she has these nice, big, strong jaws. And as you can see, she's kind of hiding from us, which is fair. But she might stick her head back out in just a second. They have these nice, big jaws because they use those jaws to feed on one of their favorite foods, which is a marsh, a snail. So those big jaws can help them crunch on those snail shells and feed on some of their favorite foods, those snails. And terrapins are important for that reason as well. So our terrapins, like I said, especially these big females, oh, there we can see her nice big head. They'll be crunching on those marsh snails. Those marsh snails like to feed on some of our marsh grasses. So those plants that we see there, those plants help to kind of anchor that ecosystem. They help to hold in things like the sand and that substrate to kind of keep erosion from happening. And if our snails get too out of control, they can eat up that grass, and we won't have as much erosion control as we might have if we have a good terrapin population that's helping keep those snails in check. So they're important for a lot of different factors in their environment. And that's one of the reasons that we want to help conserve these guys, is because they are important in their environment, much like a lot of other species. All right, let's see if our male wants to show us that tail. Let's see if we can get a little look at that. Of course not, because I want him to. But what we would see, you can kind of see how it's tucked up under here, but it is much longer, kind of like what we saw with our 2017, where it would kind of come out to about here, be much longer than that female. And one of the ways that we can kind of tell those males from females is their size, as well as that kind of nice long tail. And they'll use that nice long tail in mating. Oftentimes it will help them kind of hold, oh, there we go, we can see it. can see how it kind of helps them, might help them hold on a little bit during breeding. All right, so we've looked at our turtles. We've seen their different sizes. We've seen those eggs and how we incubate them. Now I mentioned that our turtles have something called temperature-dependent sex determination. And so the temperature that those eggs are incubating at, again, is going to determine if we have our males versus our females. One of the ways that we can know what those temperatures are of our nests, if they're not in our lab and our incubators, is through data loggers. So basically it's kind of like a thermometer that records what that temperature is, and then after that season we can take it and we can look at those temperatures. And we do that in a couple ways. So one of the ways we can use is something called a little pendant data logger. So basically it's just this little guy, so you can see it's fairly small, and we can connect this to a computer, and we can tell it to record temperature anywhere from every minute to every hour. In our lab, we do every hour, and then we put these into nests. So in the case of our terrapins, we might be down on the beach, let's say, and we find a nest. And oops, let's get the rest of those eggs back so we can see what it looks like a little better. Okay, so here's our eggs. We'll pretend like this is a nest, kind of down in the sand. And what we would do is we could take this temperature logger and we can put it in these eggs, and then it would sit there kind of in with those eggs and record what temperature those eggs are at. Once these eggs hatch, those little hatchlings crawl up and out of that nest to the surface, crawl into the water. We can come back later and we can dig up this data logger, connect it back to that computer, and we can know what temperature those eggs are incubating at. We do this with our terrapins. We also use this to record temperatures with our sea turtles on one of the beaches that we work at in Mexico. We can take these temperature loggers and we can put them into those nests. It remotely records it, doesn't disturb the eggs in any way, and after those hatchlings have emerged, we can then take that logger and know what that temperature was over the season. We tend to see changes in our nest temperatures throughout a season. So say early in the season, maybe in March, April, May, we tend to see a little bit cooler temperatures. So we often see more males earlier in the season. Then when it warms up, say June, July, August, we're getting those really hot temperatures. You guys know what I'm talking about, where you're outside, you're sweating a lot, it's very, very warm. Those warm temperatures, that translates to warmer nests, and we get more females typically later in the nesting season. Another way that we can look at those temperatures, but maybe a little bit more closely, is with this guy. So, looks a little complicated, but it's really not that bad. What we see is that we have these kind of 4 different cords, and it is connected to this box, so we protect it in this very high-tech Tupperware. It goes into this to help protect it from the sand, and what we see is that we have basically the same thing as our small one. It's just a little bit more complicated, a little more circuitry that we can see, and we have 4 different probes. However, it uses the same battery, fun fact. These little batteries right there, same battery that runs this one as well as our little guy. So then this, with its 4 different probes, means that we can record temperature at 4 different places. So if we have our nest up here, so here's our nest, what we can do is we can put these little probes, the little metal piece at the end is what records the temperature. And so we can put that, say, maybe at the bottom, and that can record a temperature at the bottom. We can also put it, say, in the middle, record a middle temperature versus maybe a top. And so we can get a little more specific on what those temperatures are of that nest by using something kind of like this that records a few more temperatures at once. Same thing as what we saw with our other little guy though. This one will connect to that computer. So here we go. You can see this little circle right there. That little plug comes out, and we can just connect it with a little cord, kind of like when you connect your phone to a computer. And we can download that and see what those specific temperatures were in those different locations throughout incubation. So those are a couple ways that we look at those temperatures, both out in the field as well as here in the lab. Does anyone have any questions so far?
if someone is interested in going into this kind of field when they go to college, like what are some steps that they could potentially be taking now if they're in high school or even middle school?
Great, so great question. Question was, if somebody is interested in this kind of work or going into this field, what are some of those steps you can take now in, say, middle school and high school to work towards this? So one thing I'd recommend is definitely those biology classes. I know I loved all of my biologies, different marine biologies, all those different science classes. I loved those. So those will give you a good foundation. You can also volunteer. So you could volunteer maybe in a lab. If you don't live close to a university or a lab, you might be able to volunteer with, say, your vet, or if you live near an aquarium or something like that, you could volunteer in those ways. You can take some camps or other classes that kind of help give you more exposure. Once you get to college, you can volunteer in some of our labs. There's different areas where you can help out with some of these projects, and that can help you give that experience and see if you really are into it and give you that experience to help kind of jump into that field. It's a really good question. Any other questions?
How often do you go down to the beach?
Ooh, another really good one. So that question was, how often do we go down to the beach? So nesting season for these guys, for these turtles that we were looking at here, is from about May, June through July, August. And that's kind of typical of our other turtle that we work with. So we also work with the Kempsworthy sea turtle in Mexico, and their nesting season is pretty similar, kind of that. Those warm summer months. And so during the off season, we don't go that often. We're mostly analyzing data, taking care of these guys, that kind of stuff, prepping things. The prep for the season starts very early. We're already starting to get some stuff together and get things ready. Once it gets closer, so let's say in April, especially in May, we'll start to go down maybe every couple weeks. In May, they go down and we set up those kind of fences and those buckets that we talked about, and we start checking them regularly. There are classes that go on at Dauphin Island, so close to that area in May, June, and July. And so some of those students are involved with us, and they will go out and they'll check those buckets. Then after that, once nesting has started with these guys, anytime that we get a female, we'll go down to pick her up, bring her back here, and typically there's about maybe a 1 day that she'll stay in the lab, and then we try and get her right back down right away as soon as she's laid those eggs, sometimes 2. If we don't have any females currently, then we still typically go down about once a week. We'll usually go down on a weekend, maybe a Friday. And we'll go down on a Friday, check stuff out, do some surveys, come back maybe on a Saturday. But it's a pretty regular basis once it's nesting season that we do go down to that beach and work with these guys. Yeah, that was a really good question. Any others? Right. Well, thanks for tuning in, guys. I hope you've enjoyed it. I hope you've learned a little bit about our terrapins, enjoyed seeing them. And thanks for joining us.